morning. I am Renu Sharma, Assistant Professor, EC Department. Today I am going to start Unit 3rd and today's first lecture. So the topic of today's lecture is Theory of Vocoders, Types of Vocoders, then Channel Estimation and Equalization Techniques. So before we'll begin with this, we'll see what is Vocoder. Vocoder is basically an audio processor that is used to transmit speech or voice signal in the form of digital data. So basically a system is designed on the basis of analysis, and at the receiver side the synthesis is done, which will going to analyze the speech signal that we are using in our day-to-day life. So vocoder is basically going to convert, as you can see in this diagram, that whatever you are going to speak, that is in the form of analog information, because it is continuously varying signal, or 1D signal is this, and it is continuously varying, its amplitude is varying, its pitch will be changed. So that will be, if you want to process that particular speech signal or analog signal, you have to use a device that will going to convert that continuous time signal into digital signal, so that you can see that this signal is converted into bits of information, or bits will be shown as 1010 in the form of digital data. So this is a kind of vocoder. So vocoder is an audio processor that is used to transmit speech or voice signal in the form of digital data. It is used as short form of voice coders. Vocoders in short, it is known as voice coder. These are basically used for digital coding of speech and voice simulation. The bitrate of available narrowband vocoders is 1.2 to 64 kbps. So this is the varying bitrate is for a particular vocoder, that is narrowband vocoder, it is 1.2 to 64 kbps. It can vary, means you can record your speech signal in this frequency range, in this bitrate. So vocoders are operate on the principle of formants. Formants are basically the meaningful components of speech that is generated due to human voice. Now, what is formant? Formant is basically a kind of component of a speech, because speech signal consists of two types of sound signals, that is voiced and unvoiced data. Depending on the sound that is produced from your vocal cords and from the vibration of the cords and from the mouth directly, then that is going to divide your visualize your speech signal into two categories, that is voiced and unvoiced signals. Now whenever a speech signal is transmitted, it is not needed to transmit the precise waveform. We can simply transmit the information by which one can reconstruct that particular waveform. So this is how the vocoder will work. So vocoder work in such a way that it first captures the characteristic element of the signal, then other audio signals are affected by the use of that characteristic signal. Like you can see that this is the model of the vocoder. This is an impulse generator whose input is an frequency control. Then there will be a noise generator. Now noise generator and impulse generator are basically going to produce the voiced and the unvoiced data. Voice data is generated by this impulse generator, and unvoiced data is generated by this noise generator. So two types of voices are generated. The which type of voice you have to select, that is decided by this switch, like if it can process this voice sound, or it can process this unvoiced sound. Now the switch position is according to voiced or unvoiced sound. It will be passed through a filter, and after passing through a filter we can synthesize the speech waveform. So this is how the speech signal will be synthesized. So this is basically an analysis synthesis kind of a combination, where the input signal is analyzed depending on the impulse generator, noise generator, and it will be synthesized after it is passed through a filter. Now vocoders are used for the voice synthesis. The vocoder takes two signals and creates a third signal using the spectral information of the two input signals. It aims to emblem the amplitude and frequency characteristic of speech signal onto the synthesis signal while maintaining the pitch of the speech signal. So a pitch has to be maintained, like whatever you are speaking, a pitch has to be maintained so that it will not be counted in noise, and whatever you are speaking, it should be audible, it should have As you know that for the male voice and the female voice both have different pitch, so the pitch should be maintained. So these are the some of the parameters that is related to the speech signal and that are used to make a vocoder, voice coding system. Now next is the speech human speech production system. Now the speech is produced from filtering operation formed by the larynx, pharynx, oral and nasal cavity. The sound channel is a physiological filter which shapes the stimulus from the lungs. Different forms of sounds are produced by changing the filtering characteristics. So whatever filter you are using, as you have seen in this diagram, that whatever filter which you are using over here, which will going to just separate this voiced and unvoiced data, and it will use to synthesize the particular system, you have to use the good quality of filter. And by changing the characteristics of the filter, like you can change its cutoff frequency, you can change the range of frequency that it can filter out, the output will going to change. So the characteristics of the filter changes depending on the position of the tongue and lips. Now you can see over here, like this is the very simple diagram which has its which has nasal cavity, then upper lip, lower lip. So what is the whatever will be the movement of this particular portion, it will going to decide that what will be the speech signal, what will be the output of in the form of speech signal, it will going to change. Now the voice sound forming starts from the lungs. Midriff muscles press the lungs and causes the over pressure to the trachea. Now the vocal cord starts to vibrate at a frequency that is called as a fundamental frequency. Now the frequency of vibration basically vary. For male it will be from 100 to 110 hertz, and for female voice it will be 200 hertz. So this is the frequency of vibration of the vocal cords. Then the main difference between the voiced and unvoiced data is that in the voice sounds have a greater amplitude than unvoiced sounds, and they are formed in narrow and closed part of the sound channel. So unvoiced sounds are similar to the random noise. So this is the human speech production system. Now this is divided into two different diagrams, like first one is the human speech production modeling, second is the equivalent synthetic speech production block. Now this diagram you can see that in this one, this is the sound pressure which will be going to pass through two types of weight functions, that is A and 1 minus A. Then after passing through this will be passed through two voiced and unvoiced excitation blocks. Then noise like signals will be generated and quasi periodic excitation signal will be generated. Then this will be passed through articulation, and then a speech signal will be produced. Likewise the equivalent synthetic model, because this is the original model, the synthetic model is like this one, like energy, whatever speech signal is produced, it is written as an energy. Then it will be applied to a tone generator and noise generator. Through this unvoiced signal will be generated, and through this voice signals will be generated. Now this will be passed through a variable filter, and then speech signal can be heard from the speaker. So this is how the speech production model will work. Now this is just an explanation of the previous diagram, like it is used to simulate the voice, as speech contains a sequence of voiced and unvoiced sound. This is basis for the operation of a voice model. Before proceeding further, it is better to understand that what is unvoiced and voiced and unvoiced data. Now voice sounds are basically the sounds that is generated by the vibration of the vocal cord. So whenever your vocal cord will going to vibrate, it will going to generate the voice data, and it has high pitch and frequency as compared to its amplitude is high as compared to the unvoiced sound. So the unvoiced sound, like the letter S, P or F is called as an unvoiced sound. These are generated by expelling air through the lips and teeth. So this is the case for unvoiced sounds. Now voice sounds are simulated by impulse generator, the frequency of which is equal to the fundamental frequency of vocal cords. The noise source present in the circuit is used to simulate the unvoiced sound. So this is how the data will be produced. Now this diagram is showing the voice encoder. this is a pictorial representation that how technically through the use of different filters like bandpass filter we have used, then rectifiers are used, how the voice will be encoded. So this is just an analog signal which is of high frequency signal and its varying amplitude. It is the speech input. Now this is applied to the bandpass filter whose variable frequency range is 200 hertz to 400 hertz. That is the band of frequency. Then 400 to 600 hertz, so up to 3200 hertz bandpass filter will be used, and there is a frequency discriminator will be there which will going to discriminate the frequency of the input signal. Then this is passed through series of rectifiers. So we are using we are using 15 different rectifiers. That is nothing. There are two types of rectifiers like half wave and full wave rectifiers. So basically diodes are used in rectifiers. Then it is passed through low pass filters. So 15 low pass filters are used and one is used after this frequency discriminator, and then it is been applied to ADC and MUX. Then the encoded voice signal will be generated. So this is the voice encoding diagram. Now this is the explanation of this particular diagram. The frequency spectrum of the speech signal that will vary from 200 hertz to 3200 hertz. It's divided into 15 frequency ranges by 15 bandpass filters. So each having a bandwidth range of 200 hertz. So here the signal is rectified and filtered so as to produce a DC voltage. In this is generated by a DC voltage which is proportional to the amplitude of the AC signal. So the input of the frequency discriminator is the speech signal. Frequency discriminator is nothing, it is followed by a low pass filter of 20 hertz. So this low pass filter generates a DC voltage proportional to the voice frequency, and the frequency represents nothing. Then the pitch. So DC voltage is nothing. It will going to indicate whether the speech is voiced data or it is an unvoiced data. So the output at all low pass filter is a DC voltage which is sampled, multiplexed and A to D converted. So we have a digital equivalent of the speech signal at the output of the encoder. So this is divided into two components, that is 200 hertz to 3200 hertz. So from bandpass filters that has been used, 15 bandpass filters we have used which will vary from 200 hertz to 3200 hertz and having a bandwidth of 200 hertz. Now this is the receiver part, that is the voice which you have encoded at the transmitter side. It has to be decoded. So the DMUX and the DAC is used. Then it is passed through balance modulator. To this balance modulator we require to insert another signal for the purpose of modulation. So that particular signal will be selected by noise generator and pulse generator. In case of this noise generator, unvoiced sounds will be used, and in case of pulse generator, voice signals will be used as an input to the balance modulator. At the output of this balance modulator, there will be bandpass filter which will again vary from 200 hertz to 3200 hertz with a bandwidth of 200 hertz. So 15 balance modulators are required, the same number that we have used at the transmitter side. Now this is been required to be added together at this adder, and then speech output signal will be there. So whatever analog signal you have transmitted, you want to transmit, it will be encoded at the transmitter side, then it will be decoded at the receiver side. Now this is the explanation of this diagram. The digital voice signal generated by the voice encoder is firstly it will be decoded. Then the decoder using a speech synthesizer produces voice signals at its output. It is generally generates an approximate voice signals. Now the digital voice signal is generated by voice encoder. Is firstly it will be decoded. then it will be using a speech synthesizer produces a voice signal at its output. So basically a balance modulator is used in analog modulation for purpose of modulation of the input signal and a carrier signal. Now here carrier signal is not cos omega t or sin omega t. We are using the voiced and the unvoiced signal, that is again analog in nature, and then it will be modulated and then it will be passed through the filter, and then you are going to get after adding the output of the 15 filters, we are getting the speech output, that whatever you have transmitted. Now however the switch position is decided by the decoder. It is because when the voiced signal is received, the switch connects the pulse generator output to the input to all the balance modulator. Now next is types of speech coder. So there are different types of, so till now we have discussed about what is speech coder, what is human speech production system. So now we are seeing that what is the classification of the speech coders depending on the coding techniques. So first one is the waveform coder, second is voice coder or vocoder, then hybrid coders, and then analysis by synthesis coder. So these are the 4 different types of speech coders. So in this waveform coders, it preserves the original shape of the signal waveform, better suited for higher bitrate coders, example the PCM system and ADPCM system. Now what is PCM? It is pulse code modulation, and ADPCM is adaptive differential pulse code modulation, that is used to generate the high bitrate coders. Now voice coders are also known as vocoders. Speech signal is assumed to be generated from a model which is controlled by some parameters. So some parameters are basically the pitch of the human voice signal, then frequency of the voice signal. So these are some of the parameters that you have to consider in the processing of the speech signal. So during the encoding, parameters of the model are estimated from the input speech signal. Then the parameters are transmitted as an encoded bit stream. Quality of the decoded speech depends on the model. Now model is basically we are taking an example, that is G.729 vocoder. So it has a lower bitrate, it is a lower bitrate coder. Now the hybrid coders are used to combine the strength of the waveform coders and vocoders. The additional parameters of the model are optimized such that the decoded speech is as close possible to the original waveform, and it has a minimum bit rate basically. So this is a condition for hybrid coders. Now analysis and synthesis, analysis by synthesis coder is another improved form of vocoder. Synthesized signals are extracted from the given codebook structure, and the parameters representing the best excitation signal and corresponding production filter are then sent over the decoder. So basically this is the example of an analysis by synthesis coder, which has its value G.729 ACELP and CS-ACLP speech coder. Sorry. Different types of vocoders are, first one is LPC vocoder, that is linear predictive coding, that uses linear predictive coding. Second one is the code excited linear prediction, that is CELP. Then mixed excitation linear predictive, that is MELP, and adaptive differential pulse code modulation, that is ADPCM. So these are the 4 different types of vocoders that we are going to see now. Like this is the speech is generated by, in case of the first one, that is then LPC vocoder, the speech is generated by inhaling the air and then exhaling it through the glottis and the vocal tract. Then the noise like air from the lung is modulated and shaped by vibrations of glottal cords and the resonance of vocal tract. So basically this is the diagram, like this is the random source which will going to generate the analog signal or the speech signal. Then it is applied as an excitation. Excitation is basically the input signal. We are calling it as an input signal. It is applied to this model whose transfer function is given by PZ. Then it is applied to the vocal tract model his transfer function is given as hz, and that will be the output as a speech signal. So the pitch frequency models the vibration of the glottal cord and generates a speech sequence of quasi-periodic excitation pulses for the voiced data, which is shown in the figure, this one. Then the pitch filter model is also termed the long-term predictor, since it models the correlation of each sample with the sample as a pitch period away. So this is how the modeling will be done. Then the linear predictive model basically forecasts the amplitude of a signal at the time m. Now this is the prediction, basically this is linear predictive coder. This is the prediction of the signal that is generated by xt. So x cap m will be there, which is equals to summation case from 1 to p AKGEC m minus k. So it is using the linearly weighted combination of p past samples, that is xm minus 1 to xm minus p, which is written over here. Now where the integer variable m is the discrete time index x cap m, it is the prediction of xm, and ak are the predictor coefficients. So this is basically the input signal. It is applied to this linear predictive coder, where delay functions are used, like z inverse are there, series of z inverse are there. The output of each of this system is xm minus 1, then xm minus 2, and so on. So this is nothing, it is the linear predictive coder, that is x cap m. This is a is equals to r x to the power minus 1 r x x. So this is nothing, it is the linear predictive coder diagram. Now next is the code excited linear prediction, that is denoted as CELP. Now one of the main advantage of the principle behind CELP is called the analysis by synthesis, ABS, and the meaning that encoding is performed by perceptually optimizing the decoded signal is a closed loop. So you can see in this closed loop, like this is the fixed code book and this is the adaptive code book. Now what is the difference between fixed and adaptive? In case of fixed code book, whatever you have written, whatever the data is stored, it is fixed. But every time when a feedback is attached, so every time the signal output will going to change and it will going to update this adaptive code book. Now the output of this adaptive code book and the fixed code book gain is being added together using this summer, then it is act as an excitation. So this is nothing, it is an input signal and it is applied to a synthesis filter. Now the synthesis filter is basically it the transfer function of this will be denoted by 1 upon az, and that will be the output of this code excited linear predictive coder. Now next one is the mixed excitation linear prediction. In this case, it evolved from the improvements and modifications to another code excited CELP. So MELP is nothing, it is the extended version of the CELP. This is also known as LPC10. The traditional pitched excited LPC coders are used as a periodic pulse rate or white noise as the excitation for an all pole synthesis filter. So MELP coder uses a mixed excitation model that can produce more natural sounding speech because it can represent a richer ensemble possible speech characteristics. So this is the extended version of the CELP. Now this is the explanation again of the MELP, that is it is based on the traditional LPC vocoder, but it also includes 5 additional features, like it uses mixed excitation, then aperiodic pulses are there, adaptive speech spectral enhancement is there, then pulse dispersion, Fourier magnitude modeling will be there. So when the input speech is voiced, the MELP coder can synthesize using either the periodic or a aperiodic pulse. So a periodic pulse are basically used most often during the transition regions between voiced and unvoiced segments of the speech signal. So this feature basically enables the decoder to reproduce the erratic glottal pulse without introducing the tonal sound. So this is the explanation of MELP. Now MELP, there are two diagrams associated with this MELP. This is the analysis part, this is the synthesis part. In this one, pitch and aperiodic signal as a flag, it will be applied to this inverse DFT, that is a discrete Fourier transform, and to this we require different Fourier magnitudes as an input. So after this passing through a pulse shaping filter, which will going to reduce the effect of the noise that will be generated inside the system before it will be transmitted. Then it will be added together, both sides, and then after addition it will be passed through an adaptive spectral enhancement. So whatever noise it will be affected, it will going to be enhanced using this adaptive spectral enhancement. Then it is passed through an LPC synthesis filter, then scaling function will be there, and the output of this will be a synthesized speech signal. So this is the NELP codec. Now next is last one is the adaptive differential pulse coding modulation, that is known as ADPCM. So in this ADPCM, it is a very efficient digital coding of waveforms. The principle of ADPCM is to use our knowledge of signal in past time to predict it in future, the resulting signal being the error for the prediction. So in the previous example includes this G.726. So in this recommendation, which currently includes G.721 and G.723 recommendations of CCITT, it is specified that 8-bit PCM word should be reduced to 4-bit ADPCM word, correspondingly reducing the bit flow by a factor of 2. So this is about today's lecture that covers the vocoder part. Thank you.